Good evening. Study with Apala from Parbin Singh. Part of the Earth as a planet. In its shapes, the Earth is commonly described as a spheroid. It has an equatorial diameter of 12,757,776 kilometer as a polar diameter 12,713.700 12,713,824 kilometer, thus showing a difference of 43.952 kilometer. The Earth shows as a equatorial bulge as a slight flattering at the poles. It has a mean density of 5.517 gram per centimeter cube, volume of 1.083 into 10 to the power 27 centimeter cube, and mass of 5.975 into 10 to the power 27 gram. At present, the Earth is the only planet known to sustain life in the family of a solar system. Recent studies of Mars have shown very vaguely that possibilities of life on that planet cannot be entirely ruled out. For scientific investigation, the planet Earth is commonly differentiated into three parts: atmosphere, lithosphere, and hydrosphere. Volume of informations have been collected about each of these parts during last 100 years or so. Artificial satellites are the latest tool for the study of the Earth, with the modern scientist following a brief account gives a more outlines of the most important characteristics of these parts. The atmosphere, the outer gaseous part of the Earth, starting from the surface and extending as far as 700 kilometer and events beyond its termed atmosphere. It makes only about 1 millionth part of the total mass of the Earth. The gaseous envelope, like the other matter, is held around the planet due to gravitational pull of the body of the Earth. It is now fairly established that the atmosphere possesses a layered structure. Different layers of the atmosphere are distinguished on a number of bases: a change in composition, change in temperature, degree of ionizations, and so on. Chemically speaking, the atmosphere is made up of a mechanical mixture of gases, commonly called air, that has a fairly uniform composition and homogeneous structure as follows. The table here, don't forget to learn the table picture this in your book. It is important. See, when you come in, say, any examinations, exams, given competition exam, it is important. So first learn table. Chemical composition of atmosphere: dry air component, volume percentage, nitrogen 78.084, oxygen 20.946, argon 0.934, carbon dioxide 0.033, and others neon, helium, krypton, xenon, it's 0.003. The above composition of the atmosphere is almost uniform up to a height of 80 kilometer from the surface. This atmospheric zone of uniform composition is sometimes referred as a homospheres to differentiate it from the overlying part that form the heterosphere, where the composition varies from place to place. Thermally speaking, the atmosphere show in an interesting variations in temperatures, with increasing height from the surface. At some level, the temperature start falling with increasing height, whereas at others level it remains constant with increasing height, and then at still other levels the temperature start rising. Thus, a zigzag curve is obtained for variations of temperature records in the atmosphere above the surface in figure 1.3. So based on thermal characters, the atmosphere is divided into following layers: troposphere, stratosphere, mesosphere, thermosphere. Following are the main characteristic of these atmospheric zone. This here 1.3 atmospheric structure of the atmosphere describes this here high temperatures and five this here we start from here 9 to 20 kilometer earth troposphere, sea tropopause is a division, and 9 to 25 kilometer stratosphere, or here in stratosphere ozone layer, ozone O3, 60 degrees Celsius, 100 degrees Celsius, 1000 degrees Celsius temperature, 20 to 80 kilometer stratosphere, stratopause, make a layer. Difference between ionosphere and stratosphere between, or 880 to 500 kilometer, or 500 to 70 kilometer exosphere. Okay, so don't forget to draw this diagram. The tropopause. It is the lowermost zone of the atmosphere, rising from the surface of the earth and extending on an average to a height of 11 km. Its upper boundary, called tropopause, lies at about 9 km above the poles and at 18 km above the equator. The troposphere contains almost 9/10 of the total mass of atmosphere. It is this layer of gases that is responsible for most of the weather, forming a meteorological process on the earth. In the troposphere, there is a recorded a regular fall in temperature at a lapse rate of 6.3 degrees Celsius per kilometer up to tropopause, resulting to as low temperature as minus 40 degrees Celsius to minus 60 degrees Celsius at those heights. The most important character of troposphere is occurrence of a strong stubble lens and a thorough mixing of the gases in this layer. In fact, the name of the layer, troposphere, was coined by T.D. Bort in 1908 mainly to indicate the process of turning over and over again of gases in this layer. Troposphere plays a great role in sustaining life on the earth. The stratosphere. It is the second layer of the atmosphere starting from the tropopause and extending up to an average height of 50 km. The stratosphere differs from the lower layer in following respect. The temperatures becomes constant for a height of 20 km above tropopause and then start increasing. It contains almost the entire concentrations of ozone gas that occurs above the earth in the form of a well defined envelope distinguished on the ozone layer. The stratosphere itself has a layered structure and there is no significant mixing and troublesome of gases in this layer. The ozone layers start at a height of 9 km above the surface and continues up to 35 km. The maximum concentration of ozone in this layer is estimated at a height of 20 to 25 km. The importance of ozone layer for the life on the planet Earth lies in its capacity to absorb a good proportions of the solar radiation, including the entire content of most dangerous ultraviolet rays coming from the sun. In this process, the gas gets itself heated up and hence becomes the cause of a higher temperature in the upper regions of the atmosphere. The upper boundary of the stratosphere is called stratopause. The ozone layer is of immense importance for the survival of life on the planet. It is a natural shield against the ultraviolet rays reaching the earth from the solar radiations. However, it has been discovered that certain gases originating from the industrialized world like carbon dioxide in increasing volumes are producing a destructive effect on the size and volume of ozone envelope. Holes or gap for being caused in this gaseous layers that are becoming increasingly dangerous for the life systems of the planet. On such ozone hole was detected by NASA in September 2000 over the Arctic that was of a size of 20 million square kilometers. Since then, a global scale efforts has been accelerated binding all the nations to curtails generations of ozone destroying gases by introducing alternate technologies. The mesosphere. This is the third thermal zone of atmosphere which begins at stratopause at about 50 km above the surface and continue up to height of about 80 km. It is characterized with a steep fall in temperatures that may go to as low level as minus 100 degrees Celsius at the upper limit of mesosphere. D. The thermosphere. The fourth and the last zone of the atmosphere start about 80 km and extend up to 500 km. And beyond in this zone, temperatures start rising once again and reach 1000 degrees Celsius and above. This zone is, however, very rarefied in nature. The individuals gas particles being separated by considerable distance, even being heated to such a high degree, these particles pose no threat for a space traveler because there is a little chance of their striking him in significant concentration. It is the solar radiation at these height that is most dangerous. The ionosphere is a spatial zone recognized with the atmosphere. It starts from 80 km and extend upward to variable height. Atmospheric gases at these heights absorb a great part of solar radiations coming to the earth. In this process, these gases break up into ions or electrically charged particles. As a result, this part of the atmosphere is made up entirely of ions and hence is designated as the ionosphere. The degree of ionization is not uniform throughout the ionosphere. In fact, scientists have distinguished five layers, making these zones which can be distinguished on the basis of degree of ionization. The most strongly ionized layer is located at the base of ionosphere and is designated as a D layer. In it is also sometimes referred as a Canley heavy layer, CD layer. After the name of its discoverers, scientists have taken due advantage of the existence of ionosphere. It has proved a boon for long distance radio communications by virtue of its property of reflecting long radio waves. The region of atmosphere beyond 700 km it is termed exosphere. It is believed to be an extremely rarefied low density and high temperature regions with minimum atomic collision, and the subject of a structure of the atmosphere is being constantly enriched with the findings from artificial satellites. Much new information is being gathered about the physical, chemical, electrical, thermals, and other properties of the atmosphere through new tools of investigation.